In this lesson, we are going to be factoring polynomial equations. And if you recall from when we were doing multiplying, we were multiplying the difference and sum of cubes. Now we're going to be factoring the difference and the sum of cubes. So these are the special patterns that you can use to do factoring for the difference and the sum of cubes. Let's start by reviewing some of our basics. So when we start factoring, we always want to take a look for the common monomial factor. So when we have 8x plus 16, we want to take out the common factor, which is an 8, and dividing both terms by 8, our remaining binomial will be x plus 2. If you recall, when we have our differences squares, when we're going to factor, we want to have the same binomial, but one of them will be plus and one of them will be minus, and we're taking the square root of each of those terms. So we have x plus 3 and x minus 3. And that's our pattern of the difference of two squares. In our perfect square trinomial, remember that we have our patterns for the sum and the difference. So when we're factoring, we simply take the square root of the first term, which is x, the square root of the second term, which would be 3, and because all of the terms are positive, we know that this will be plus and that our binomial is squared. We can also write it as x plus 3 times x plus 3. In general, when we're factoring, we want to take a look that we don't have a common factor, and in this case we don't. So since it is a quadratic, our factors will be two binomials. So what do we multiply times itself to get x squared would be x, and what do we multiply to get 6 that has a sum of 5, and that would be 2 and 3. And if you want to check that you have factored it correctly, we already know that 2 times 3 is 6, which is our last term, and x times x is x squared, which is our first term. So when you're checking to make sure, you really want to do the O, the outside terms, and the I, the inside terms, to be sure that the 2x and the 3x have a sum of our middle term, which is 5x. In our next, let's see if we can practice factoring, and if these are not factorable, we will write not factorable. So we have our quadratic, our trinomial. Take a look if they have anything in common. They don't, so we're going to draw our two sets of parentheses, and we know that x times x gives us x squared, and we want to know what two numbers can we multiply together that will give us 4, but also have a sum of 4. So that'll be a positive 2 and a positive 2. Hopefully you recognize that our next quadratic is the difference of squares, so we draw our two sets of parentheses, and we have our x and our x, and we have one of these that is plus 2 and one that is minus 2, and that gives us our difference of squares. In our next example, we have our quadratic. We'd first take a look for a common factor, which we do not have, and so we know that we have x and x. So we ask ourselves what two numbers will give us a negative 4 as a product, but give us a sum of 3. And that would be a positive 4 and a negative 1. In our next example, we take a look for our common factor, and there isn't one. So we will factor and giving us x times x for x squared, and I want two numbers that multiply together that give me negative 4, but when I add them together I get negative 3. In this case, that's going to be negative 4 and positive 1. When we take a look at our next example, we want to see if there is a common factor, and in this case there is. So we're going to divide both terms by 3, which gives us x squared minus 4. And then you should recognize that x squared minus 4 is the difference of squares. So when we factor that, we would have x plus 2 and x minus 2. In our next example, we want to take a look to see if there's a common factor, and there is, which is 3. So I'm going to divide all three terms by 3, which gives me x squared minus 2x plus 1. And then I want to factor if possible, because we always want to factor completely. So x times x would give me x squared, and 1 times 1 would give me 1. However, I want to multiply those two numbers together to give me a positive 1, but when I add them together, I want to get a negative 2. So that would make both of these negative. You can also rewrite this as 3 times the quantity x minus 1 squared. In our next examples, we have the sum and the difference of cubes. So if you want to recall the special pattern that we had for the sum of cubes, we would be able to factor that very quickly. You could leave our first in this pattern, but I would prefer if we always had our patterns written in standard form. So if you recall from our special pattern, when we're factoring, the first thing that we do when we have a sum of cubes is we are going to factor the a and the b. So this is going to be x plus 5, taking the cube root of each of those. And then the rest of the pattern is that we are going to have the square of the a value, so that's going to be x squared. Then we have the difference, which means subtract a times b, so subtract 5x. And then we are going to add at the very end the b squared, which would be 25. In our next example, we have 64 a to the fourth minus 27a. The first thing that we need to do is to take out the common factor, which is a. So now we have 64 a to the third minus 27. And notice that this term and this term are perfect cubes, and so we have the difference of cubes, which is our special pattern. To factor that, don't forget we have our common factor of a. We're going to take the cube root of the first term, which would be 8a, and the cube root of the second term, which would be minus 3. Then with our special pattern, the first term is a squared. So, it shouldn't be 8a, it should be 4a as the cube root. So we are going to square our first term. 4a times 4a is 16a squared. Then we are going to multiply the a and the b together, and we need to have that be a positive product in our difference of cubes factoring, which is going to be 12a. And then we have adding our square of our last term, which would be 9. In the next example, we also have the difference of perfect cubes. So when we factor that, we take the cube root of each of our terms, which is x and 3, and that will be subtraction. And then we square the first term, which is x squared. We multiply the two terms together. A times b would be 3x, and we'll add that. That's part of our pattern. And then we square the last term, which would be 9. Those are the patterns for the sum and the difference of cubes. Factoring is really about practice and being able to recognize patterns. So let's do a few more examples. Let's take a look at this one, 64x cubed plus 27. I hope that you recognize that each of these are perfect cubes, and so we have the pattern sum of cubes. So again, what we do is we're going to take the cube root of this term, and the cube root will be 4x, and then the cube root of 27 is 3. So we have 4x plus 3. Then to continue our pattern, we square the first term, which is 16x squared, and then we want to subtract the product of the a and the b, which would be 12x, and finally we square the last term, which would be plus 9. Taking a look at our next example, 8x cubed minus 1. Again, I hope you recognize that both of these are perfect cubes. So to factor, we're going to take the cube root of each. The cube root of 8x cubed is 2x, and the cube root of 1 would be 1. So we have 2x minus 1 as our first binomial factor. Then, to find the others, what we're going to do is square the first term. So 2x times 2x is 4x squared, plus the product of the a and b, which would be 2x, and then we have plus, or the square of the last one being positive. Negative 1 times negative 1 is 1. In our next example, I need you to recognize that these are both perfect cubes, so we're going to take the cube root of each for our first binomial. So we'll have x minus 7. And then to finish factoring, we square the first term, which is x squared, plus the product of the a and the b, which would be 7x, plus the square of the last term, which is 49. In our next example, we have the sum of cubes. So what we're going to do is to take the cube root of each. So we have x plus 4. And then our trinomial, when we finish factoring, would be the square of a. So we have x squared minus the product of a and b, which would be 4x, plus the square of b, our last term, which would be 4 times 4, which we have 16. In the next example, we want to take a look at, we have an x to the fourth, and hopefully you recognized that we have a common factor, which is 2x squared. So we're going to divide both of these by 2x squared. So that gives us x squared minus 100. And then we need to recognize that the x squared minus 100 is the difference of perfect squares. So we continue factoring into x plus 10 and x minus 10. In our next example, we need to take a look for any common factors. We don't have any. So it is a trinomial, so we are going to factor it. What times itself gives us x to the fourth would be x squared and x squared. What two numbers can I multiply together that give me negative 24, but when I add them together I get positive 5? That's going to be a positive 8 and a negative 3. And when we take a look at our remaining binomials, if we look at the last one, it is subtraction, but we do not have two perfect squares. And when we take a look at this one, we have a binomial that has an x squared, which is a quadratic, but there is no middle term, and since it is plus, we cannot factor that one anymore either. Next, we'd like to look at the special pattern of factoring by grouping, and that is where we are going to take two terms and decide what their common monomial factor is. So they both have a 9 in common and they have an x squared in common. So we have, when we divide them both by 9x squared, we have x plus 2. And then we take a look at the second two terms, and we see that they have a negative 4 in common, so we're going to factor that out, which gives us x plus 2. Here's the cool part. We are able to take the first and the second monomial factors and put them together to create our first binomial. And then our second binomial, x plus 2, repeats, and that becomes our second factor. Now, if you take a look, the reason that this is possible is we're actually doing the distributive property in reverse order, because if I multiply 9x squared times x plus 2 and negative 4 times x plus 2, the result will be that previous step. And then if I multiplied 9x squared times x plus 2 and negative 4 times x plus 2, I would be back at my original. Now we decide if we're done factoring completely, but this first binomial is the difference of perfect squares, so we can factor that as 3x plus 2 and 3x minus 2, and then we have x plus 2. And that will be factoring by grouping and also making sure that we have it factored completely. Please be sure before you factor by grouping, you notice that it is 4 terms, it is a trinomial, a polynomial, I mean to the third degree, and that it is written in standard form. Let's take a look at a couple more examples. First, we want to make sure that it's written in standard form, and it is. So we now factor by pairs. We take a look at our first two terms and divide by the common monomial factor, which is going to be 3x squared. So when I divide by 3x squared, I have x minus 4. taking a look at the second two terms, what they have in common is a positive 2, and when I divide, I have x minus 4. We create our first factor by putting together our common monomial factors, which is 3x squared plus 2, and then using our second factor as our binomial that they had in common. And then we take a look and make sure that we can't factor any further. So we have 3x squared plus 2 and x minus 4. Let's take a look at our second example on this slide. First, make sure that your polynomial is written in standard form, and we're going to factor by grouping, which is factoring the first pair. The common factor is x squared, so we have x minus 5, and our second two, we have in common a negative 9, and that gives us x minus 5. I hope you've also noticed that each time we do this, that this binomial must be exactly the same, and that also can give you a hint of what the common factor is, because you do want to make sure that the binomial is exactly the same. So we have x squared minus 9 as our first factor, putting together our common monomial factors, and then we have x minus 5 as our other factor. But we haven't factored completely because this is the difference of squares, so that gives us x plus 3 and x minus 3 and x minus 5. Now this has been factored completely. Let's take a look at another example. First, check that it is written in standard form, and then we want to factor the first pair. They have a 16x squared in common. So when we divide, we get x minus 3. And then we take a look at the second two, and you might think that they don't have anything in common, but they always will have something in common. And in this case, they have a negative 1 in common. And the reason that I know that is because I want to make sure that this second binomial is x minus 3. To get the negative x to be positive, I would divide it by negative 1, and to get the 3 to be negative, I want to divide that by negative 1. So now we'll put the monomial factors together, which gives us x squared minus 1 as our first binomial, and then we have x minus 3. Please recognize that 16x squared minus 1 is the difference of squares, so that's going to be 4x plus 1 and 4x minus 1. And our other factor will be x minus 3. So now we have factored this polynomial completely. Our last example on this slide, make sure that these are written in standard form, and we want to check what these two have in common, which is 2x squared. Then we have x minus 6 as our binomial. In the next two, we see that they have a 5 in common, so that'll be plus 5, and that gives us x minus 6. When we combine our monomial factors to create our first binomial, we have 2x squared plus 5, and then we have x minus 6. Even though this is an x squared, which is a quadratic, and that would give us a hint to continue factoring, we only have a binomial, and it is a sum, so that cannot be factored any further. So that is our factors. When we take a look and review, please remember that you want to take out the common monomial factor first. Check if you have any special cases, which might be the difference of two squares, a perfect square trinomial, the difference of cubes or the sum of cubes, and lastly, check for a special pattern, which would be factor by grouping. And when you're factoring by grouping, make sure that your polynomial is written in standard form.